कौन सा वो थोड़ा माइक्रोफोन
Please don't hesitate to ask questions.
I have any question? आगे दे दो क्या है? The student from textile mechanical सिग्नल देना है?
नहीं ठीक है नहीं ठीक है I hope the examples are clear to you up till here what we have done. Yes, please.
As far as the causality of an
Causality. It's not causal.
of an element is concerned.
Yeah.
So be it a mechanical or electrical system, it is following a different trend. But in textiles, like we are using things viscoelastic in nature. So for that, should we have to derive some equations from basic?
See, if you are talking of viscosity, if you are talking of viscous, say a viscous resistance, uh, a viscous resistance, let's say, then you have the viscous friction related to the relative motion, okay, between the layers of the fluid, where you have relative motion between two surfaces. You have the friction which is proportionate to the relative motion of this. That means, so here you are having a case of the frictional force being proportional or a function of this velocity. Okay. So in this case, it is like if it is linear, it is a linear frictional force. If it is a rotary frictional force, as in a torsional damper, you can have a torsional damper. I can understand you are dealing with a lot of spindles and weaving machines.
Yes,
so it's possible that you may have torsional damping. In the example which I have taken here, well, even in the example of the DC motor, tomorrow I'll explain to you how we account for damping. In fact, I think we have it here also today. Well, here we have the damping here. You can see this here. So here we have this damping, and it's a linear viscous damper, but it's of the torsional type, rotary damping. You see, here you have the angular velocity, okay, and here you have a frictional moment that is created, which is proportional to this angular velocity difference. So you can make a measurement also. You can measure this using a signal arrow. We have put a signal arrow. So actually, it's no power is being transacted here, but it's something which is used just to measure what is the angular speed and what is the position of the mechanical side. I'll explain this in more detail tomorrow. Yes.
Sir, whatever you tell that, whatever the question he has asked, that is textile material is viscoelastic. As well as whatever the mechanical parts are rigid.
I attended to the viscous part, not the elastic
no, sir,
part.
Viscoelastic material is there.
Yes.
And textile material is a flexible, and whatever the mechanical elements are the rigids. But then how we can apply this flexible material relation with this one?
No, it is not necessary that mechanical elements are rigid. It's not
mostly
like that.
as compared to whatever the engineering material, like whatever you are using, like whatever the parts are rigid, and textile materials are normally as compared to that it is flexible.
What about the example you have given for the rigid material? Flexible materials, how?
Yeah.
How we can apply
see,
it?
say for example, in suppose you take a string, you just take a let's say a piece of string itself, or a fiber, let us say, a textile fiber. And let's assume that it has just elastic properties. Within a particular range, it just has elastic properties. You are just pulling it. Okay? There is some tension that is going to develop on it. But then after some time, there is also internal damping. Now it's up to you what kind of model you wish to use for the stiffness as well as for the damping. Okay? So you may use a Voigt model, you may use a Maxwell model, you may use a Kelvin model. Okay? So there are different types of models that you could use. Not only that, you may find that if you extend it more, you go beyond a particular limit, then what happens is that we call it the phenomenon of creep, where for the same force, after some time you find that there is a permanent deformation or there is extension taking place. Okay, and I am sure that happens in textiles as well. So in that case, you can model that also. In that case, you will have to add another element. So I think we will take this as an example tomorrow, where we can discuss this different effects. We can take care of creep, we can take care of this Voigt model or the Maxwell model or the Kelvin model, and then we can actually analyze fibers in different standard models maybe, and how this modeling can be done.
Anyone? Any question? So, thank you, Professor Anand, and thank you for your participation. Again we will meet tomorrow at 5:30, but you should be punctual about the time. You should come 10 or 15 minutes before. I think, I hope you will do it. Thank you.